In part 7, 4.7, it tells us, or it asks us, to write which table represents a linear function. In order for it to represent a linear function, that means your triangle y, or your pattern for your y's, needs to be consistent, and it has to be the adding or subtracting the same number of times consistent. And then your pattern for your x's also needs to be consistent, which means you have to add the same or subtract the same value every time. If we look at f, and I just look at my y values, that's a +1, that's a +3, and that's a +2. Because I'm adding different numbers every time, that is not linear. Whereas if I look at h, this is going to be a +1, +1, +1, but you have to be careful because if you look at your x's and check the x pattern, that's a +2, that's a +3, and that's a +6. And so even though your y pattern is the same, because your x pattern isn't the same, that makes it not linear. If you look at g, this is +1, +1, +1, and your x's are +2, +2, +2. Since the pattern for your y's is consistent and your pattern for the x's is consistent, that makes g the linear function. In number 12, it says, which of the following represents a nonlinear function? Well, we're given equations here, and in order for an equation to be linear, the exponent has to be 1. If it's anything other than 1, that makes the equation or the function nonlinear. So if we look at f, the exponent to my x value is 1. Remember, anything that doesn't have an exponent is always an imaginary 1. So once again, for g, there's no exponent, so it's an automatic 1. For h, it's still a 1, which makes f, g, and h linear functions. Whereas if you look at I, notice how your exponent's 2. That makes it nonlinear. If you recall, if there's an exponent of 2, that graphs a parabola, which is nonlinear. In number 13, it says, which table represents a nonlinear function? Well, in order for it to be nonlinear, the pattern can't be consistent. It's the opposite of what happened in number 11. So if we look at our pattern, this is +2, +2, +2, and that's +1, +1, +1. That makes it linear. Remember, we're trying to find something nonlinear. In C, it's -2, -2, -2, and +1, +1, +1. That makes it C linear as well. If you look at B, this is -1, -1, -1, +2, +2, +2. That makes that linear. So D is +3, +5, and +7. So since it's different values every time, that makes it nonlinear.